Good day everyone, Rico Rix once again, and welcome back to another episode of our MATHFLEX. So for today, we'll have the last of our series on parabola. So this time, we'll try to learn on how to graph our parabolas. So without further ado, let's go directly to our board work. Okay, so let's start with the basic. If we have here like y is equal to x squared, so as we learned before, so if you have the x is squared here, so that means we expect that our parabola is opening up since we have a positive coefficient here. So that means our parabola is opening up. Okay, so to graph this one is we have to assign values of x and then we'll try to get the corresponding values of y. Okay, so we have to establish set of points. So you have your x, then you have your y here. So if x is 0, so that means our y value will be 0 also. Therefore, our vertex will be at 0, 0. If x is 1, so 1 squared is 1, so y is also equal to 1. And then if x is 2, so 2 squared is equal to 4. And then since our line of symmetry or axis of symmetry will be our y-axis, so therefore if you assign negative values of x, we'll have the same values of y. So if you will assign values of x on the negative side, we'll have the same values of y on the positive side. So therefore that is, if x equals to negative 1, that is negative 1 squared, that is 1. And then if you have negative 2, you'll have positive 4. So to graph this one, is you should have like x is 0, so that's our vertex, and then sorry, I hope you can still see me here. So x is 0, and then x is equal to 1, y is equal to 1, x is equal to 2, y is equal to 4. So 1, 2, 3, 4, 2, so this is 2. Also on the other side, x equals to negative 1, and then x equals to negative 2, y is equal to 4. So let's try to graph this one as smooth as we can, but I know that cannot be achieved. Okay, so let's see. Okay, so therefore, this will be our y is equal to x squared. Okay, so this will be our parent graph or parent parabola, wherein we have here as our y is equal to x squared. So let's try another function. Okay, so what if we have this function wherein you have like y is equal to x squared plus 1. So in this case, your vertex now will be at, okay, as we learned before, so this will be y minus 1 is equal to x squared. So vertex now will be at 0, 1. Okay, so let's try to assign some values of x so we can get the values of y. So let's try from this one. So at x and then y. So at x 0, of course, y will be 1, and then at x is equals to 1. So x squared, that is 1 squared, that's 1 plus 1, y is equal to 2. And then x equals to 2. So 2 squared, that is 4 plus 1, that is 5. And then let's try negative values. Okay, so x equals to negative 1. So y is equals to 2 also. And then x equals to negative 2. Y is equal to 5. So I think this set of points are enough. So let's try to graph this second function now. Okay, so vertex at 0, 1. So that is at x equals to 0, y is equals to 1. At x equal to 1, y is equal to 2. X equals to 1, y is equal to 2. At x equals to 2, y is equal to 5, so 3, 4, 5, so that means at x equals 2, y is equal to 5. Okay? Just want to make sure. Okay. At x equals to -1, y is equal to 2. At x equals to -2, y is equal to 5. So let's try. I'll try to connect this one, these points. Okay. So this will have now y is equal to x squared plus 1. So why I presented this one, so you would observe now that we basically the same nature of graph, or our graph is basically the same, or technically the same. It's just that with the addition of 1 here, so we move our graph 1 unit up. Okay, so that means this is, the graph is shifted 1 unit up. Okay. So on our next function, we'll see how the graph will look like if we shift units from left or right. So let's see the next example. Okay, so we have another case here wherein we have y is equal to x minus 2 squared. So how it will be, also how does it look like if we try to graph this one. So again, we go back to our basic. We have to assign values of x, then we try to find the values of our y. So at x is equal to 0, y is equal to, so that is -2 squared, that is 4. Okay, so by the way, our vertex here, as we have learned before, it would be at 2, 0. Okay, so this is y minus k, and then it's equal to x minus h squared. So that means k0, h is positive 2. Then let's try x equals to 1. So 1 minus 2 is -1 squared, that is 1 also. Okay. If x equals to 2, of course, that's our vertex. Okay. Y is equal to 0. If x equals to 3, okay, so that is 3 minus 2, that's 1 squared, that is 1. And then x equals to 4, so that is 2. So 4 minus 2, that's 2 squared, that is 4. So I think this set of points are enough. So let's try to graph now. Okay, so our vertex at 2, 0, so that means 1, 2, this would be our vertex. At x equals to 1, at x equals to 1, okay, let's try it. At x equals to 0, y is equal to 4. At x equals to 0, y is equal to 1, 2, 3, 4. This one. At x equals to 1, y is equal to 1. So this point also, okay. At x equals to 2, y is equal to 0. At x equals to 3, y is equal to 1. 1, 2, 3. At x equals to 4, y is equal to 4. So that means somewhere here. So if we'll try to graph this one, it will be like this. Okay? So this will have now an equation wherein x minus 2 squared. So what have we observed here? That, okay, it's basically the same graph, but we move only our graph 2 units to the right. Okay, 2 units to the right. Okay, so basically we always go back to our parent parabola, and then with the addition of some values there, so we know how to shape our parabola. It's either going up, okay, shaping up, or shaping down, right or left. So it depends on the nature of your function. Okay, so let's have another case. So another case here wherein you have a function wherein you have a coefficient before your x squared. So let's try this one. Y is equal to 4x squared. So how does this 4 affects our parabola, or okay, the nature of our parabola? So let's try to assign some more values here. So you have x, y, then at x is equal to 0, y is equal to 0, right? So that means vertex will be at 0, 0 again. And then, let's try values of 1. So 1, so that means your y value is 4. At x equals to 2, y is your, so that's 2, that's 4, that's 16. And then at x equals to negative 1, let's try on the negative side. So that means 4. And then negative 2, that is also 16. Okay. So let's try to grab this one. So at x equals to 0, y is equal to 0, vertex here. And then at x equals to 1, y is equal to 4 already. So this one. At x equals to 2, y is 16, up there. Okay. Also here, at x equals to negative 1, y is equal to 4. At x equals to 2, 16, so somewhere there. So if we try to grab this one, it will be like this. Okay. Sorry for the grab, but I just want to point out something here. So that means this is y is equal to 4x squared. So that means the coefficient here, the greater the coefficient here, it makes your graph, okay, narrower, or closer to, or narrower, sorry. So this is how the coefficient affects your graph. So the greater the value here, your graph gets narrower, okay? If you put a smaller value here, say for example 1/4, so that means your graph will get wider, okay? Because it makes your y values smaller also, and your x, it makes your x value smaller and your y value higher. So that makes your graph more wider, okay? So I think that's enough for today. I hope you learned something from our lesson today. So this is the end of our parabola series. We'll have circle next time. I hope you learned something again. So please don't forget to watch, like, subscribe of course, and hit that notification bell for you to get updated on our succeeding videos. Until next time guys, bye-bye. Nigel. Very good. Punta doon. Nigel, come. Very good.